Okay, Assalamualaikum and hi everyone. So the next topic will be the unit tangent and normal vector. So this one is from the extension from the derivatives of vector function. So as we have discussed on the previous videos, we differentiate the vector function with respect to t. Okay, so now we want to look at what is the example that we can apply that particular differentiation of the vector function. Okay, so here the continuation of the derivatives of vector function, we have a tangent vector. Okay, before the topic here is called as unit tangent and unit normal. But before we want to compute the unit normal and unit tangent, so you have to know what is tangent vector first. So the word of tangent is, the ideology of the word of tangent is similar as if you have a regular function, for example, x cubed. Okay, then you want to differentiate. So this is nothing to do with the vector function yet. So this is just a regular function. So we compute this. So this is called, the application of this differentiation is to compute the slope, right? We can compute the slope. We can compute the rate of change if you have t, or this one slope, or we can see that it is a tangent, which means that as I mentioned before this, if you have a curve, let's say a curve on 2D. So this is your curve. So now so this one is supposed to be x squared. Okay, so you want to compute the slope at this point, or the tangent. So when you have a slope, then you can evaluate the tangent line. You can you can find the tangent line. Tangent means that has to do with the slope. So the tangent line will give you something like this, tangent. Okay, so you know the slope and you know the point, so you can get the linear equation of this tangent line. So but then now we extend the understanding into the vector function. So we have a tangent vector. Okay, so what is a tangent vector? So suppose the vector function r, it can be differentiated. Is differentiable at the specific t, which is t naught, and the r prime t is not equal to 0. So we can say that the r prime t is defined to be a tangent vector. Okay, so whatever vector, so let's say your vector r is given by t square 2t and t cubed plus 1. So when you compute the r prime t, which is differentiate r with respect to t, then you have 2t, 2 and 3t square. So if they ask you to compute the r prime at specific t, so let's say is equal to 1, at t equal to 1, so you got 2, 2, 3. So this is called, sorry. So this is called, I'm sorry about that. So this is called as a tangent vector. Okay, so now look at the word of unit tangent vector. So when there is a word unit here, when you have a word unit, when you have word, just a second, I'm trying to underline. Hopefully it's work. It's okay. So the word of unit vector, unit tangent vector. So you have to apply the formula of unit vector where the tangent vector itself is divided by its magnitude. Okay, so you have to use the result of r prime, which is tangent vector, and divide it by the magnitude of the tangent vector. So this result, which will give you a new vector form, is called as a unit tangent. Okay, so the unit tangent is denoted by capital T. So that is unit tangent. So now we look at the unit normal. So for the unit normal, since there is a word of unit and then normal, so you have to use your unit tangent and then differentiate the unit tangent and then evaluate its magnitude. Then you divide them, the differentiation of the unit tangent divided by the magnitude of the differentiation of the unit tangent will give you unit normal. So in this case, if the question is asking for from R, they ask you to obtain the unit tangent, and after that obtain the unit normal. So that is very favorite question in exam. Okay, so if your capital T vector, which is unit normal vector, is wrong, so meaning that your unit normal also, of course, wrong. So be careful when you compute the unit tangent vector. Okay. Alright, so this is the graphical representation, the relationship of the unit tangent vector and unit normal. So you will see the unit normal vector here. But then from this diagram, you can see the relationship between the. Okay, remember last time on the previous video, v is just like a velocity. So how can you obtain the velocity vector? So you have r and then differentiate r respect to t, right? So that is the tangent vector actually. Okay, so the computation, the formula is the same, but the way you elaborate is different. So now before this we have v, so v is the velocity vector, but the process to get the the vector v or the velocity vector is the same, which is r prime. So this one is also can be represented by r prime t. So this is r prime t, and it has the same direction as the unit tangent, because as I mentioned before, the vector t and the vector tangent, okay, the tangent vector here and the vector t here, they have a same direction but different magnitude, because the tangent vector or velocity vector is larger than the unit tangent, because the unit tangent vector is always equal to 1, because it is a unit vector. Unit vector, the magnitude is always equal to 1. So they have a same direction. Okay, and then so it's just like you have if we relate the understanding, this understanding in vector function with the regular function, which is, let's say we have the same curve. Okay, so now if we know the equation of this. So let's say we know that one is just like y is the function of x, so whatever it is. Okay, and then you want to compute the slope at that point. So now so this is y, so the dy over dx is the slope, right? So now you can compute the slope at this specific point. So when you know the slope and you know exactly the point here, so you can compute the tangent of that the tangent line of that point along the curve. So now the idea is similar, but then we are talking about the vector function. So they instead of we can just have the value, we can also have the direction. So now we got extra information because we are using the vector function, where we can determine the magnitude of the vector, and we also know its direction. Okay, so and there is r here. R is a position vector. So how can you label the position vector? So it should be an arrow from the origin and point to that point. So that is vector r at specific t. So I put t naught here. Okay. So that is the idea. If someone asking you what is the actually the unit tangent and the vector tangent. Okay, the vector tangent or the tangent vector, sorry. Okay, so the tangent vector is v, and they have the same direction but different magnitude. And of course they have the same direction because we got the unit tangent from the tangent vector here. Remember, this v is actually r prime, and then v over its magnitude is actually unit tangent, or r prime over the magnitude of r prime. Okay. Okay, so here the statement says that the unit tangent points in the direction in which the object is moving. Okay, so in this case, what does that mean? Okay, let's okay, I share because using that I cannot jot down, so maybe this one. Yeah, okay. So particle moving, remember from the I think from the first slide or the just in the beginning of the vector function, I already share with you the curve here, the curve in space is just like a particle moving along this curve, and they should have a direction. So in this case, let's say I'm using this diagram. So now let's say so this is your initial point. So you can say that this is the position vector of r at t. Maybe I put t equal to 0. So that is your first point. And then after that, you compute. Okay, you just plug in for the specific t. So maybe this one. So the next. So this one. The next position vector. And that one is r at t maybe equal to 1. And then so on. So you can see very many points along the curve. Okay. If you put some values of t, and t should be in some interval a to b, for example. So let's say this is your endpoint. So now then you label that. So this is your position vector at t equal to b. So that is your endpoint. Okay, let's say now they ask you in exam, they ask you to determine the unit tangent of the given vector function. The function should be given. Otherwise, you cannot do anything. So you must be given the vector function. So they ask you to obtain the unit tangent vector of the given r. So let's say they give r rt. So now you compute, and then after that they ask you to label. Okay, so let's say when you sketch that, so you have, I will teach you how you can get this. So just a general explanation first. So let's say you got this value. So you can see that, so you got this vector, this direction from the information that you get from your answer. Okay, you need to compute, and then you can get answer, and from the answer given, the answer that you obtain, so you can sketch this line. So now they will give you a direction. So you know that now if someone asks you, so in what direction the particle moves along the curve, it can be this way, or it can be another way around. So how can you know that? So it's from your direction that you have sketched. So it is obtained that the direction is over there. So meaning that for any point, so they will also using the same direction. Okay, so they are just all the time for any t, they will on the same direction. I mean, so let's say here, let's say we choose a point over here, and then I And then you draw, you sketch the unit tangent for at that particular point, and you will have this direction. Okay, and maybe you have this, you choose this point, and you plot or you label the unit tangent at this point, and you will see that the direction will be in this way. So you can see that they are moving in this way, from the left to the right. So it depends on the information provided. It's not always the time they will move from the left to the right. So it depends on the information provided. Okay, so that's why says that tangent points in the direction in which the object is moving. Okay. Okay, so now from the next diagram here, so this is the relationship between unit tangent and unit normal. Okay, so unit tangent and unit normal, they are always perpendicular each other. Perpendicular, so it's just like this one and this one supposed to be T. So at all point, of course the magnitude of them is equal to 1 because they are unit vector, and then the dot product between T and N is always 0 because they are always perpendicular each other. Okay, so that is the property of N and T, the very important information about both of them. So the unit normal points in the direction in which the object is turning. What does that mean, turning? So if you look at the diagram here, how can you explain the T, capital T, and the capital N? Just now you said that the direction of T always point to the direction of the particle moving. See, if the particle is moving from the left to the right, so the T will follow through. So meaning that for this one, if it's moving left to the right, so let's say you want to investigate the unit tangent and unit normal, so we know that by using this curve, so the T always point over here. Okay, and similarly, if you have want to investigate or calculate the unit tangent and they ask you to label, so the T always point to that way because it follows the direction of the particle is moving. And if you investigate the unit tangent of that point, and the direction of unit tangent is always point over there. So because of, as I mentioned before, the idea of unit tangent is the same as the tangent line. Okay, but now we got extra because it should have the arrow. Before this, just a regular function, you just provide the line without arrow. For example, this one, you just provide the tangent line, but now you have extra because we deal with a vector, then you can have a direction. Okay, so how about N? N, as mentioned here, N points in the direction in which the object is turning. So the extra information provided here, N points to the inside of the curve in the direction the curve is turning. So you can see that, so it starts turning. So then you know this is T, and the perpendicular of T should be N. Similarly over here, if this is your T and the perpendicular of T is N, but point inside. So that is the property of unit normal. Okay, similarly the point here, of course we know this is unit tangent and the perpendicular, because we know that the behavior of the T and N, they are always perpendicular each other. So you might wonder whether the direction of N is up here or down here, because we know that both can be perpendicular. But just remember the information provided here, N points to the inside. So inside mean should be which one? So this one is, so this is turning, start to have something turning here. So, and this is your t, and this is considered as, obviously this is called outside, right? Outside, and this one inside. Just like if you have yeah, something like, so I'm using the wire here. So this is your, where is it? Okay, hopefully you can see that clearly. So this is your particle, your curve in space. So it's something turning, right? So how can I make it turning? So this is open, so start to turning. So if we have this line, can you see that? So this one, this is your capital T vector, and the unit normal this way or down here, because of they said that it should be point inside, so this is considered as inside. Okay, so that is for the characteristic of the unit normal and unit tangent. Okay, so by combining all the information that we have, again we use the same diagram as from the first just now. So now you can see that just now we have just r, I already explained that, and we have t, and now you have r prime, which is v. Just now I put that one as the v vector, velocity vector, r prime. Now we put extra information, since now we already talked about the unit normal. So again I say that t always point in the direction of the particle moving, and then n always point inside to the turning area. So it starts to turning, right? And this one point inside, where this one has to do with the r double prime. R prime is v, and then from the result here you can have t, and then you differentiate t, you will get n. So the r double prime here has to do with the unit normal. Okay, but unit normal, since it is a unit vector, so the magnitude is always equal to 1. So r double prime should be longer. I mean, can be longer or shorter. So we have another example here. So this is another curve. Just like a helix shape, right? So the particle moving clearly seen from this arrow. So that is the direction. So where is your, let's say we are investigating. So they will give you at specific point, because you can have the point over here, you can have the point over here. So they, in exam, they will ask, they will guide you on which t that you have to check or to find out. So let's say you are interesting to get the unit tangent at this point. So now you apply the formula and you manage to compute the unit tangent, and then when they ask you to sketch the graph, and after that label the unit tangent, so meaning that you have to show the direction, I mean the arrow like this. Okay, so this is, you will get this from your calculation. So I will give you an example after this. So this is a position vector at this particular t, a particular point. Okay, and then if they ask you to plot the n, so where is the n should be? Should be on the same point here, and then perpendicular to t. So whether we have perpendicular, so it's supposed to be like that, right? Whether this way or that way. So which one? So should be point inside. Okay, so this is not the answer. This is for unit normal vector. Okay, so there is a definition about the smooth curve. Smooth curve, what does that mean? Smooth curve here, the graph of the vector function defined by the given vector r is said to be smooth at any interval of t where, okay, the r prime, the tangent vector, is continuous, which means that the r prime t cannot be equal to 0. So you can say that the vector functions is smooth. You can see that smooth, just smooth. Okay, but however, down here is not smooth, because you can see here we have the r prime, which is the tangent, is infinity. So this one you can have some slope. This one you can have some slope. Also here you can evaluate the slope. This one also you can get the slope. But for this particular form, the slope is, you know, the slope, if you have the horizontal line, so this one, the slope considered 0. Okay, and if for this one should be some number. And then, but if you have this one, oh sorry, vertical line, so this is infinity. It's not, it doesn't mean that very large, but it does not exist. So when the tangent or the slope does not exist, so we can consider that that particular vector function is not smooth. Okay, so that is the definition of smooth curve.